Well, happy Friday. I've been asked to basically try to do a reasonable follow-up. Alyssa did such a great job, I hope I can even come close to that. The Owens Lake Dust Mitigation Project started in 2016. The project actually bid late in 2015. The project was awarded towards the end of the year 2015, and the actual start and construction date of it was actually starting in early January of 2016. This particular project, LADWP, Los Angeles Department of Water and Power, this is an ongoing, this is a very interesting history behind this. And actually starting in the early 1920s, Los Angeles, the city population of LA was around 200,000 people plus. So they were having a problem determining how they were going to get fresh water for the population of LA, because they knew that LA was going to continue to grow. So what they elected to do was they elected to go up into Owens Valley, into Owens Lake, and they put in a water channel to basically take water from the Owens Lake and start supplying the LA area. As a result of that, what it caused was it caused this lake basin that was there to become a dry lake bed. Over time, that lake bed became so serious that the dust control and everything for that lake was actually sending dust particles as far as Japan. So it was determined that the health of that dust that was being created there, because the lake bed is very costly. And so over a long exposure period of time, people were getting sick. So there was a major lawsuit that took place in the 90s, and out of that came a mandatory mandated requirement by the courts that Los Angeles Department of Water and Power was required to take over the dust mitigation responsibilities of the lake. So since the early 2000s, LADWP has been slowly developing dust mitigation control process for this lake. The phase we did was now phase 9 and 10. This particular phase has actually brought this up to 99% of dust mitigation control for the entire Owens Lake area. This particular portion of this project was just a little bit under, it's 3.62 miles of Owens Lake, of the entire area that's out there that was under this project as far as being upgraded. The total area that was affected was 48 square miles. So it's a very large area, to say the least. This will give you an idea of an aerial view of looking down on this lake as to what kind of a basin this is. It's a combination of wet and dry. The project award date, February 2nd, 2016. Notice to proceed was issued January 28th. Our original contract value was $17,599,000. We ended up with added change orders on this project with $2,344,632, which brought it almost to $20 million for the total contract value. LADWP is the owner of the project. General contractor was OHL, and the NA stands for National. OHL is from Spain, and they brought their development division to the United States, and this was their first project in the United States. Tesco Controls was the system integrator on this project. System integration is all the control, development, and responsibility for controlling all the various pump stations and control functionalities for this project, which consisted of a very detailed type of control system for this project. Everything that's on this project, because you can see it's an open lake process, was all done with telemetry, radio telemetry controls. So every one of these pump stations and mechanical pump stations, lateral valve stations that they have on this property, it all has a PLC, which is a programmable logic controller that allows all the process information that's going on, whether it's monitoring status or whether it's controlling functionality, that reports back to their main SCADA. Their main SCADA operation is the primary control system that oversees and controls all the functions and monitors all the functions of the entire lake. All the communications is done by line of sight. So the antenna towers that are on each one of these sites has to be tall enough, and there is a specific aiming and communications requirement between those and the master site. Nothing can be constructed or built to block that line of sight. If it is, then they have to move and put in repeater towers that allow that information to eventually get to the main control station so that all control points can communicate with each other. I was the project manager over this job. Superintendent was Steve Thomas. Steve Thomas, my hire date will be 5 years in November. Steve Thomas came on board just about a month after I did. The Owens Lake ponds, lateral shallow flood, managed vegetation, require water for dust mitigation and compliance with environmental mitigation agreements. The lake's water fluctuates throughout the day due to automatic schedules that run over 150 shallow flood laterals and 50 managed vegetation blocks. So the process that I was explaining earlier is basically what this is creating is creating a giant sprinkler system for the majority of the lake basin. They have some of the lake basin areas to where they've actually developed a process of using a fabric with rock in order to control. And in those particular areas, they're doing that because there's a lot of areas that are in this lake that are very soft. And as you'll see by a few photos that are coming up here in a few minutes, you'll see exactly what I mean. This is one of the DMU sites. The DMU basically is a mechanical site, and as you can see by the pumps and the functions that are there, that what this does is this takes water that is pumped through the entire lake basin to these DMU sites, and these DMU locations, they'll take the water from Owens Lake or Owens River and they pump it through the lake for the purpose of irrigating and using that sprinkler control system that you saw earlier. These drawings, this is reflective of all the underground direct burial cable that we had to install on this project. There were various sites scattered throughout this project that required all of these underground duct banks and direct burial cable, and how everything is being installed through this entire lake. This particular feature right here is, right now, we had almost 17 miles of direct burial cable to install on this project. So every one of these cables, as they route through the project, they all go to what they classify as load break junctions. So these are above ground handholds, and they have features on them that allow the cables to terminate onto a bus into these special above ground junction boxes. And so by doing that, it eliminates splices underground. So there's no cable splicing allowed underground. Everything is above ground. These various areas represent the areas of the responsibility of the expansion of this project. And as you can see, when you link all these together, then you can see why there were so many miles of cable to travel between one location and the next. This is an example of one of the blow-ups of one of those sites. And you can see how the dotted line and the various dashes and what have you is on here. You can see those little box locations. Each one of those locations is a handhold, it's an above ground handhold with a load break junction. So in the process, all the cable was special ordered on this project with Southwire. And it's not all the same size, there are various sizes depending on the amount of loads, because it was all 5 kV, 5,000 volt distribution. Some of the challenges on the project was the winds up at the Owens Lake. The highest recorded winds during the course of the project was 110 miles an hour. This is one of the shelters that, these shelters, as you'll see later on, you'll get a better picture of what one of them looks like. But this is what happened in one night. It took this particular project and it completely destroyed everything on the site. There was nothing left. I talked about issues before about how soft it is in some locations. There's actually, unfortunately, I don't have the photos of one particular site where the entire site was, through the course of the project, there was a site that was out there that started sinking. We thought they were going to completely remove the requirement of building and developing that particular site. Well, they decided not to. They decided that they didn't think it was going to sink anymore. So they went ahead and had everybody construct the site. As you'll see, unfortunately, I don't have a picture of it. I wish I did, because right now I'd like to have an update because it's almost gone. So they have a complete site that is disappearing into the lake bed.
Wow.
And we tried to warn them that this was going to happen, but they elected to proceed. So one of the areas that we fully developed as part of this project is soon to be disappeared and not to be seen again. One of the practices throughout the course of this job, and the one practice that we're using on the majority of all our projects, is developing prefab templates. So all these plywood templates that you see with all the holes that are drilled in them, they're representative of eventual conduits that are going to be installed for particular pieces of equipment on these slabs. So it seems like when you look at these sites and you look at the finished product that's out there, it doesn't look like there's much out there. Well, I'll let you be the judge. So you can see that dimensionally how they're laying everything out. It's a matter of, so that no matter the building itself eventually, because all the equipment has to sit over the top of all these conduits that stub up, and you'll see that later on also. The buildings, and now the buildings, once they pour the slabs, the accuracy of this is, we virtually have zero tolerance. That's how accurate it has to be. This is one of the well sites. This particular one is going to have submersible pumps to go into it, and you can see the water table that we're having to deal with out there in the course of the project. That particular slab right there represents about 2 miles of conduit underneath that slab. So here's the equipment. Now you can see with the pad forward, you can see these just little bitty stub ups that are there. It doesn't look like there's hardly anything above the underground. So here are the enclosures. All these are custom built enclosures to fit depending on what the application is. So that particular enclosure there is a variable speed drive. So this is going to be for a one of the mechanical pump stations. Other controllers include switchgear, the flow indicators for transmitters, for all the flow meter controls and everything for the functionality. Once the gear is set, this is what one of the shelters look like when they're actually maneuvering the shelter to go into place. This particular project, I would do this so that hopefully Beverly would be here today so we could get special recognition for this. This project was a true representation of the core policies of this country, and that's acoustic. The quality of the work, which you saw earlier, is very representative on this project. The safety on this project, we had 45,030 man-hours worked on this project with no recordable lost time incidents. Teamwork. As you can see in this photo, teamwork is a must. Everybody has a job to do. Everybody has a task to perform. And in order to pull this off, you can see how many guys are involved in setting that shelter. You can see how many people were involved in setting the equipment within the shelters. Steve Thomas did an incredible job. Unfortunately, the field does not always get the recognition that they should. It's easy for us to get some recognition in here because we're more in the limelight than they are. But make no mistake that the personnel that work for this company represent this company in the best way. Integrity. It goes without saying that every employee that I've ever met working for this company has without a doubt the strongest integrity of any company I've ever seen. Commitment. I hope moving forward from this day and prior to and from here on that the commitment that this company is pursuing is of the highest standard in the industry. Our biggest challenge in this project was Craig Barnes. He was a senior LADWP electrical engineer overseeing this project. And of all the people that I've ever met and come to work with in my history of all the years I've been in this industry, he was by far the most challenging. But as a result, this was a review, a performance review that he did for us to help us qualify for another project. And the top part of this was special thanks to Steve, myself, and the team for everything that we did. And all the years that he's been with LADWP, not one time is he ever giving a recommendation for any contractor. So that's pretty special. And as you can see, he gave us an excellent all the way across the board. And actually, how did we do on that job? Did we qualify for that?
We still have 6 months.
What's that?
We still have 6 months for them to review it.
Okay. Well, hopefully that'll all pay off. So, last but not least, I personally want to thank Beverly and Scott for doing something that is so rare in this industry, and I mean this from the bottom of my heart. This is the finest company I've ever worked for, and I've worked for a lot of them. It takes a long time for a company to develop its image and who they are and what they are. And I don't know how you guys pulled it off, but you have done exceptional, for sure. And the team of people that's here today, I've come to know every one of you personally. I've come to know you in the business place, and it's an honor and a true respect from me to work with you. I look forward to everything we move forward on and to try to achieve everything the best we can and do the best job that we can. That's it.